Hello, this is Babam. This is a little demo of a pygame game that I made called Hexomata. Um, it's a two-dimensional, obviously hexagonal automata. The the game will start in a random field like this. The notes you're hearing and colors you're seeing are linked in that each color has its own note, and each color represents how many neighbors a cell has. So yellow is 0 neighbors, orange is 1 neighbor, red is 2 neighbors, and it goes up like that through the rainbow. So instead of starting with a random field like this, we can blank the screen and start an initial pattern and see if it grows. This one doesn't grow. One block won't grow. So we'll pause it again and we'll make 3 blocks and see if that grows. And that grows. So the sides and tops and bottoms of this tile set wrap over to the other side of the tiles. So this automata does not have boundary issues with the edges. However, the pattern will wrap from one side to the other and then collide with itself when it grows. But we still have some symmetry here down the middle. And we have some blinkers that will prevent this pattern from ever going dead. Some random starting patterns with this rule set, 2-3/2, will settle down into a dead pattern, and that will be detected and displayed in the bottom left corner like that. So we got some options here. We've got our rule set, which I'll explain in a moment, and we've got our frames per second, which is currently set to 5, and our tile width, which is currently set to 50. Now you can get a better sense of these patterns and how they grow with a smaller tile width. So I'm going to set this to 10 and hit enter. You have to hit enter in these fields. So that starts us with a random field. You can see much more resolution here now, and the hexagons are tiny. But let's do a blank and watch this pattern that we just established with the starting seed of 3 tiles, and watch this grow. You'll notice the sound will be very quiet at first and it will grow as the object takes up more space on the screen. So there you go. The rule sets are given in some numbers, a forward slash, and then some numbers. And this is very simple. The left side of the slash represents the survival rules, how many neighbors will survive, or how many neighbors it takes to survive. In this case, it's 2 or 3. You don't need a comma or anything between those. The right side of the slash is the birth rules. So inactive cells, the black ones, will be tested to see how many neighbors they have. And if they have 2 in this case, they'll come to life. So we can change these rules. Let's try 1234/14 and hit enter. And then we can hit pause and we can see what this does with the new rule set. And you'll hear new notes now because we have some yellows in there. But we can do a blank and we can start with our 3 our seed of 3, and we get this pattern growing. So I didn't show you, there's a very common artifact in the original rule set will go blank, and we will try a not a 3, but we'll do 6, a hexagon basically of 6 hexagons, and we'll watch that one grow. And it turns into this little blinker, swirly blinker thing. So you see this with a lot of rule sets when you start with a seed of 7 tiles like that. So let's try another one. 056/016. Enter. So we just converted that existing pattern into the new rule set. And because it's got zeros in it and 6s, we get the green background, which eventually gets replaced. You can hear the sound going away, or quieter. And that's that pattern. That's starting from what we had on the screen already. If we start from a seed of 3, it's very similar. So there you go. You can play with this and discover interesting patterns and start interesting seeds. Let's just change the grid width to 15, or the tile width. A little bit bigger tiles. This button here shows you the grid itself so that you can see what's going on a little bit better. This number here shows the numbers, but the tiles are so small that the numbers just overtake the screen. If we set this back to like 40, then the numbers show up like that. Show you the tile number in case you want to figure out what's going on in here. This render button, you shouldn't press this unless you know what you're doing. This render button will output each frame of the growth and this screen that you see to a PNG file, an image file, in the render folder from where you got this executable. The images can then be taken with FFmpeg and assembled into a movie with the settings that you want. So you can directly capture everything that you see as individual images with the render button. But be careful, you'll fill up your hard drive with images if you leave it running. So you have to click it again to stop it. Anyways, that's my little pygame game that I worked on here over the last few days, and I thought it was kind of interesting, so enjoy playing with it.